Hello, welcome once again to Chemistry Mail. Today on Chemistry Mail, our business is to look at part 3 of electrochemistry. And in this part 3, we'll be considering rules guiding oxidation number or states. Subscribe to our YouTube channel and make sure you follow us on Facebook. Alright, let's begin this journey. Now, in the first part of electrochemistry, we looked at the concept of oxidation and what? And reduction. And then in the second part, we considered the concept of oxidation number and the two main uses of what? Oxidation number. So in this third part, we want to see the rules that will help us in carrying out calculations of oxidation numbers of what? Elements in compounds and also in radicals. So let's look at these rules. Now the first rule is this: oxidation number of hydrogen is +1 in all compounds except in what? Except in metallic hydrides, where its oxidation state is -1. So this is trying to tell us that we have two possible oxidation states of hydrogen. Now, in all other compounds that are not metallic hydrides, the oxidation state of hydrogen will be +1. But in metallic hydrides, the oxidation state of hydrogen will be what? Will be -1. So what is important now is for us to know what we mean by metallic hydride. Now, metallic hydrides are compounds that are formed between hydrogen and metals only. So any chemical compound that contain only metals and the word hydrogen, those compounds are said to be what? Metallic hydride. So in a metallic hydride, as far as it's a metallic hydride, what we have here will be metal and the word hydrogen. Metal and hydrogen. So any compound that contains only metals and the word hydrogen. In some cases, we may have more than one metal. Yeah, more than one metals in what? In metallic hydride. We may have two metals. So any compound that contains a metal and the word and a hydrogen only, they are said to be what? Such compounds are said to be what? Metallic hydride. For example, I have sodium hydride, I have calcium hydride, I have aluminium hydride. You see, this is a metal, this is hydrogen, this is a metal, this is hydrogen, this is a metal, this is hydrogen. So once we have a metal and hydrogen, the compound is what? A metallic hydride. And in all these compounds, the oxidation state of hydrogen will be what? -1. Will be -1. But in the other compounds that are non-metallic hydride, the oxidation state of hydrogen will be +1. If we have something like sodium hydrogen triosocarbonate 4, this is not a metallic hydride because in this compound we have other elements that are not metal. It's not just sodium hydrogen that we have here. We have carbon, which is a non-metal. We also have oxygen, which is also a non-metal. But metallic hydride will only contain metals and the word hydrogen. Like I said, you can also have a metallic hydride containing more than one metal. For example, in lithium tetrahydroaluminate 3, this compound now in this compound, this is also a metallic hydride. Why? Lithium is a metal, aluminum is a metal. So this compound consists of metals and the word hydrogen. So here also, the oxidation state of hydrogen will be -1. So it is very important that you know what we mean by metallic hydride, because it's only in metallic hydride that the oxidation state of hydrogen will be what? -1. In all other compounds, the oxidation state of hydrogen will be +1. If you have sodium hydrogen triosocarbonate 4, the oxidation state of hydrogen here will be what? Will be +1. If you have hydrogen sulfide, the oxidation state of hydrogen here will still be +1 because sulfur is not a metal. So hydrogen can only have oxidation state of -1 in metallic hydride, where the hydrogen combine with metals only. I think that is very clear. Okay, that's on rule number 1. Now let's look at the second rule. The second rule is on oxygen. We say that oxidation state of oxygen is -2 in all compounds except in peroxides, where its oxidation state is -1. Someone will say, why did we single out hydrogen and oxygen to talk about the oxidation state? If you look at the definition we gave concerning oxidation, you see there are two elements that are involved. And these two elements are hydrogen and the what? Oxygen. You remember that we said that oxidation is addition of oxygen or removal of hydrogen. And that's why the basis of these rules will also, be around hydrogen and the what? And oxygen. So that's why we are not actually talking about other elements apart from hydrogen and oxygen. So oxidation state of oxygen is -2 in all compounds except in what? Peroxide. Now peroxides are compound formed when we have oxygen to oxygen atom having a single covalent bond. When you look at the covalent bond in oxygen, we have this. If you have done chemical bonding, that's the structure, because it's divalent covalent bond. Yes, the pairing of electrons in the outermost shell occur twice. Let me just illustrate this. So we have this. Oxygen has 6 outermost electrons. 6 outermost electrons. So if I draw this, so we have 6. So if another oxygen joins with this, another 6 outermost electrons. So the two coming from this one will combine with this, so they will pair one bond, they will pair one bond. So when you have oxygen molecule, it's like this. But in a compound where you have just a single bond between oxygen, a single covalent bond between oxygen atom, that's compounds that we call peroxide. The commonest is the hydrogen peroxide. Hydrogen peroxide. This hydrogen peroxide, you remember that water is this. So this is not peroxide, this is water. So water is this. So this hydrogen peroxide. Hydrogen peroxide. And in hydrogen peroxide, there is a single bond between the oxygen atoms. So in such compounds, that's peroxide, the oxidation state of oxygen will be -1. Yeah, it will be -1. The commonest we will come across is this hydrogen peroxide. There are others. You can talk about sodium peroxide. This one is sodium peroxide. This sodium peroxide, and so on. So such compounds, we have oxidation state of -1 for what? For oxygen. But in the rest of the compounds that are not what? Peroxide, oxygen will have oxidation state of what? Of -2. Such as if you have calcium triosocarbonate 4, the oxidation state of oxygen here is -2. In water, the oxidation state of oxygen is -2. In tetraososulfuric 6 acid, the oxidation state of oxygen is -2. So in all other compounds, the oxidation state of oxygen is -2. It's only in peroxide that oxygen will have oxidation state of -1. Okay, now the third rule is this. Oxidation state of an element in free state or uncombined form is what? 0. An element is in free state or in uncombined form if that element is existing as a molecule or as an atom. So if I have sodium atom like this, or I have chlorine molecule, I have oxygen molecule, I have hydrogen molecule, I have nitrogen molecule, I have calcium atom, I have copper atom, or 1 mole of copper also. At this state, the elements are free. They are not combined with any other element, so we say they are free because they are either existing as molecule or as what? Atom. So when an element is not inside a compound, for example, if I have potassium triosonitrate 5, now this potassium is not free because it's in combined form. It combined with nitrogen and oxygen in this compound now. So this potassium is not free. It's not in uncombined form. So it's not free, right? But this potassium is free. Now this nitrogen here is no longer free, but this one is what? In a free state. This one is not free because it's inside what? Inside a compound. It's inside a compound, so it is not free. So when elements are free, that is, they are existing separately as an atom or as a molecule, their oxidation states will be what? 0. Will be 0. The oxidation state will be 0. But here, the oxidation state of potassium will not be 0. You cannot just say the oxidation state of potassium will be what? 0 here. You can't do that because it's not in free state. Yes, it's not in free state. Now, an element can still stand alone and yet not in free state. For example, this calcium is standing alone, it's in free state. But this calcium, even though it's standing alone, it's not in free state, it's in ionic state. So the oxidation state of this is not 0. Rather, it is equal to the charge here, and that is +2. But this one is free. Yeah, it's free. If I have sodium triazole nitrate 5, this sodium is not free, this one is not also free. Yes, this one is not also free. Let's assume that this sodium is married with nitrogen and with children. You cannot see a married woman walking along the road with the husband. This is the husband, that's the wife, and then you have the oxygen, 3 children. Now, if you just look at it, just look at this compound. There's no way you start talking to sodium and say, are you free? Are you single? You already see that it's in combined form. Yes, it's in combined form, so it's not single anymore. It's not free. So you cannot start requesting for sodium's hand in marriage because sodium is not free. It has combined with something, and you can even see the product of their combination. Don't mind me. Now, if you have this sodium is very much free. But this one is not free. Even though this sodium did not go out with the husband on that particular day, this particular sodium went out with the husband, nitrogen, and the children, oxygen. But this particular sodium did not go out with the husband on a particular day, but this sodium is wearing wedding ring. You can see the charge. The wedding ring is the charge. So it's also telling you with the wedding ring, I am not what? I am not free. All right. So you now know what we mean by an element being free or an element being at a state of not combining with other elements. So when you see an element standing alone but it carries charge, that element is not free. It's not. But when an element exists as an atom or as a molecule separately, that element is free. When an element is inside a compound, that element is not free. Okay. And we say that when an element is free, the oxidation state of that element will be what? Will be 0. Okay, we have the fourth rule: oxidation state of single ions such as sodium ion, calcium ion, chloride ion, oxide ion, the aluminium 3 ion will be equal to what? The charge on the what? Ion. So the oxidation state will be equal to the charge on the ion, as we can see. So the oxidation state of this sodium here will be +1. The oxidation state of calcium here will be +2. That of aluminium here will be +3. That of oxygen here will be -2, and so on. So for a single simple ion, the oxidation state will be what? The charge on the ion. Okay? Now, oxidation state of common group 1, group 2, and group 3 elements are +1, +2, and +3 respectively. Yeah, I know you're already respecting yourself, so it's respectively that we have here. So if we look at this now, group 1 element, when you do periodic chemistry, you will know how we find group. For example, sodium is 281, so the group of sodium is what? Group 1. So because sodium is in group 1, the oxidation state of sodium is +1. You look at magnesium. Magnesium is 282. The group of magnesium corresponds to the valence electron. That's how we find group. You need to study periodic chemistry together with particulate nature of matter, electronic configuration, for you to understand that. Then, because magnesium is in group 2, the oxidation state of magnesium is also +2. The oxidation state of sodium is +1 because it's in group 1. So you must note that, because they are all vitals. They are all vital for this our calculation in oxidation number. Very, very important. That's why you must know this rule. Then the next one, the charge on a radical is equal to the sum of the oxidation states of the elements in the radical. Now we know that a radical contains 2 or more atoms with a charge. So if we have something like XO4 2-, This tetra also suffers 6 radical. So this is a radical. This also a radical. This one is a radical. So we are saying that for a radical, the charge on the radical, how did we get the charge? By adding the oxidation states of the element in that radical. So the oxidation state of sulfur plus the oxidation state of oxygen will give us this -2 we are seeing here. The oxidation state of nitrogen and that of what? Oxygen will give us this -1. The oxidation state of hydrogen plus that of carbon and that of oxygen will give us this charge, which is -1. So when we are trying to find the oxidation state of an element in a radical, this particular rule number 6 will play important role. So the sum of the oxidation state of the element or of the constituent elements in a radical will give us the charge on the what? On the radical. So if I add the oxidation state of sulfur and the oxidation state of oxygen in this radical, I'm going to have -2. If I add the oxidation state of nitrogen and the oxidation state of oxygen in this radical here, I'm going to have -1. And the same with this particular radical. We have 3 elements here. So the oxidation state of this, which is hydrogen, added to oxidation state of carbon, added to oxidation state of oxygen, will give us this charge, which is -1. All right. The 7th rule. Sum of oxidation state of all the elements in a compound is equal to 0. So if I have a compound, we have so many compounds. I have potassium triosocarbonate 4. Water is even a compound. Ammonia is a compound. This is a compound. This is a compound. This is a compound. So in any compound, if you add the oxidation states, of all the elements in a compound, you are going to have what? You are going to have 0. So the sum of the oxidation state of all the elements in a compound will give us 0. So oxidation state of potassium plus oxidation state of carbon plus oxidation state of oxygen will be equal to 0 because this is a compound. Unlike in radical, where the sum of the oxidation state will give us the charge on the radical. So there is no charge here, we have 0 charge. So here, the sum of the oxidation state will give us what? 0 for compound. Likewise, in water, oxidation state of hydrogen added to oxidation state of oxygen will give us 0 because this is a compound. Oxidation state of nitrogen added to oxidation state of hydrogen will give us 0 in ammonia because ammonia is a compound. Then finally, you will notice that every time I'm writing oxidation state, I always put a sign. You see that? I always put a sign. You cannot write the oxidation state of any element without the word, without the sign. Very important. So make sure you always add signs when you are writing oxidation state of an element. So if you calculate oxidation state of an element and you have 5, don't just write 5. You must tell us whether it is +5 or -what? -5. Don't say, oh, in mathematics 5 is 5. Even if I did not put +5, they know that if I write a number in maths and there is no sign, the sign is plus. Please don't even go with that argument. You must first of all understand the principle of oxidation number and also follow the rule. Very important. The rules have already stipulated that we must write signs with the word oxidation number. All right. So far so good. I believe that you have mastered this rule. There is need for you to go through the rules over and over again. Very important, because without these rules you will find it difficult doing calculation using the concept of oxidation. That's calculation of oxidation number will be practically impossible without this rule. All right, thank you for watching our video till now. Make sure you continue to enjoy all videos on our platform. We are on YouTube, Mathematics and Mathematics Mail 1. We're also on Facebook, Mathematics and Science Men. I'm also on Facebook, Engineer Ike Okechukwu. Thank you for following us, and God bless you.